All right, we're going to talk about float on. It says, even if things get heavy, we'll all float on. All right, already we'll all float on. Don't you worry about it. We'll all float on. All float on. So, moving on, the learning goals, what we're trying to accomplish in this lecture, students should be able to distinguish between intensive and extensive properties. Here's two definitions that you should be able to tell me, and then use the equation density equals mass over volume. And so those are our two main things that we're trying to accomplish in this lecture. Now, what we should already know coming into this, that objects will sink or float depending on their density. The density of water is 1 gram per cubic centimeter, and remember that that is the same as grams per milliliter. Same thing. And lastly, that density can be calculated using this formula. You should have some kind of formula chart or something like that. That equation should be given to you. Now, what we can learn from the lab, the mass of the modeling clay varies depending on how much modeling clay was used. So, not every single person made the exact same size of shape that you were trying to make with the modeling clay. Some were a little bit different when you found the mass of it. The volume of the modeling clay varies depending on how much modeling clay you used as well. So if you used a lot, then you have more volume. If you use a little, you had less volume. And the same thing with the mass. But what we should have seen is the density does not vary as mass or volume change. So even though the mass went up and the volume went up, if you made something that was larger, the density should have stayed the same. This brings us to the two types of properties that we're going to talk about. Extensive properties, and these are properties that change as the amount of a substance changes. So the more we have of something, the more extensive properties are going to change. We can see this a lot with mass. So as we increase the amount we have, mass increases. Another one we can see is length. As you increase the amount that you have, then it's going to become larger. Some other extensive properties that we have, we've already talked about length and mass. We also have area, because area is just a mathematical equation of length. That is the measurement of 2 dimensions of length. Volume, which again goes back to length, is a measure of 3 dimensions of length. And then weight, which that is the force of gravity that is pulled downward caused by Earth. Try to see if you can think some other ones up and bring them into class and ask your teacher. Intensive properties. When we're looking at intensive properties, those are properties that remain the same as the amount of substance changes. We use this a lot in qualitative analysis, so when we're trying to distinguish things. Basically what happens is, a great example of this is density. It's probably the best one that we'll use, that you will remember because it goes back to that lab. This is just the density column, so you can see that you have different substances all throughout each level right here, and they separate out because of their densities. Now, density is something that never changes. If we have 1 milliliter of water, or if we have 1,000,000 milliliters of water, the density of that water will still be 1. So intensive properties don't change depending on how much you have. Some basic intensive properties: boiling point, specific heat capacity, malleability, solubility, pH, color, viscosity. All of these are example of intensive properties. And what we can kind of see with these is these really help us determine what something is. And it really, you can narrow it down. So if you're trying to distinguish between two different unknowns, intensive properties are really good to use to distinguish those two things. So let's jump into some examples. It says, which of the following properties can be described as extensive properties? So we are looking at extensive properties. And remember, we go back to the definition of that. What is extensive properties? Extensive properties are properties that change as the amount of a substance changes. So we're looking at something. What's going to change as the amount of substance changes? Well, density is definitely or volume is definitely an extensive property. Density is not. Mass, we know that it is. The more we have, the more mass we have. boiling point is not, and reactivity is not. So the only two extensive properties we have will be volume and mass. On to our next example. It says, which of the following properties would be best in determining the identity of an unknown substance? Remember, anytime we're trying to identify the identity of an unknown substance, we want to use our intensive properties. So boiling point would be a great one. Mass wouldn't. We really couldn't tell if this beaker was filled with something and this beaker was filled with something else, two different substances. We couldn't put them on a balance, and that wouldn't really tell us anything about it. Weight, that's just going to be basically a product of mass. Length, again, that is going to be an extensive property, and volume would definitely be an extensive property. So really the only one that would really help us in determining it would be boiling point. Last question we have, or last question in this section. It says a forensic pathologist obtains a sample of an unknown chemical taken from the home of a murder suspect. That sample initially was 100 milliliters. It spills, and as it is being transferred to the lab, leaving only 5 milliliters of that sample left. What properties can be analyzed by the pathologist and hold up on cross-examination? So when we're looking at this, the one thing that we have to understand is we can't really do anything with extensive properties because we lost 95 milliliters. So anything that was dependent on the amount of substance we have, we can't use. So the only properties that we can look at would have to be intensive properties that we'd have to look at because we only have 5 milliliters left. And we know if we have 5 milliliters left, well, intensity properties don't matter on how the amount of substance that we have. Now, jumping a little bit into density, what density is, we talked about it a little bit. The definition of it is just the ratio of the mass to the volume. So it's our ratio that we have. It is that equation, density equals mass all over volume, and that here, that's just a ratio for us. Density is constant for all homogeneous mixtures. So it's constant for anything that's basically the same throughout. And you can look at these things that they're not really changing throughout. Okay, now the equation that we have here, let's define and look at each variable. D, that's going to be our density. It's the degree of compactness. The unit that the official SI unit for it is kilograms per cubic meter, but we don't use that in chemistry because we like to deal with small things. So the unit that we use for density is grams per cubic centimeter. So it would be this right here. But really, we can also write this, remember, as grams per milliliter, and that really means the same thing. V, which is down here, that's our volume. That's the amount of space taken up. It is in meters cubed, but remember, chemistry, we use milliliters, or we're going to use that cubic centimeter. And then mass, which is the amount of matter that we have, that's at M on top, measured in kilograms, but remember, in chem, we deal with small things, so we just measure it in grams. Let's jump into a question. You place a solid piece of iron into a specially designed beaker. The beaker is then put over a very intense flame. Describe the density of the metal as heat is continually added to the iron. So when we're looking at this, a solid is really, really compact. Okay, so when we think about it, it's very compact. And what is density? Density is the measure of compactness. And so and this is just, we can picture this, little dots that I'm drawing, it's just the picture of a solid, really close together, really compact. As those particles heat up, well, they start to spread out. So start to spread out a little bit into a liquid so that they can flow. And then in a gas, they're really, really spread out. So the compactness is basically nothing. So what's happening is as we add that heat to the iron, the density will constantly go down. The compactness of it will go down. Moving on to our next question. On this one, it says the following data is taken from the lab. What is the density of the unknown object? So remember, all density is density equals mass all divided by volume. We have our mass, it's right here. That's our 520 grams. Now, if we're looking at this, the other two things that we have is we have a height and we have a diameter. And if we're looking at this object that's right here, it is a cylinder. So what we're going to do, if we have the mass already, we're searching for density. That means the only thing we need to find is the volume. So we'll go ahead and use the equation for the volume of a cylinder to find the volume. So our equation for the volume of a cylinder is going to be V equals pi r squared times our height. And that's the equation for the volume of a cylinder. Now, r is obviously radius, and so we have a diameter, so we're just going to divide that by 2. And what we'll get is 6.1, and that's going to be our radius. We plug this into our equation here. So radius goes here, height goes here, and that will give us a volume. The volume that we should get is right around 2343.82 is going to be our volume. Plug it into our equation, and we should get a density right around 0.222, and that would be grams. And we could say milliliters, but since we have centimeters right there, we'll say cubic centimeters, so cm3. And that's going to give us our density. Onto our states of matter. Now, there are 3 common states of matter that you see every day: the solid, liquid, and gas. There are 6 recognized states of matter in the scientific community, and these states of matter vary in density. When we're looking at solid, the state of matter in which an object has a definite shape, a definite volume, very little movement, and is generally the most dense. A liquid has an undefined shape, a definite volume, and free movement of individual particles. That's where we get the word fluid, that it moves as a fluid. It's less dense as a solid, with the exception of water, that solid water floats in liquid water. And then we have gas, which gas is an undefined shape, undefined volume, free movement of individual particles, and it's less dense than a liquid and a solid. When we're looking at these, another one that we have that kind of gets grouped in there with it, you probably might need it for this class, is a plasma. Now, a plasma is a gas that has had its electrons removed. What we call this is an ion. It's been ionized. So it's had its electrons removed and it's become ionized. It has an undefined shape but a definite volume. And that's one of the 4 that we really talk about in this class. Now, phase transition, which phase transition is just a way of saying when it moves from one state of matter to another. And it's to changing the energy. A substance can change the phase. So if we add more heat to something, or heat is removed from a substance, then what we have is we have a change in phase, or a phase transition. Solid to a liquid, we know that as melting. Liquid to a solid, we call it fusion. More commonly, it's just freezing. Solid to a gas, we call this sublimation. Gas to a solid is a crystal lattice formation. Gas to a liquid is condensation, and liquid to a gas is vaporization, which we probably know vaporization by its more common name, boiling. Let's look at some example questions. It says, which of the following would have the highest temperature? Liquid nitrogen, solid nitrogen, or nitrogen gas? Well, when we're looking at this, the particle that has the highest temperature is the substance that's going to be moving the most. And gas is definitely going to be the one with the highest temperature. It's going to move the most. Next one says, label the following states as solid, liquid, or gas, and justify your answer using the clear method. So when we're looking at this, the clear method, remember, is conclusion, evidence, reasoning. So basically we want to state our answer. So what we would do is our conclusion, or our answer, we would say that the first one would be a liquid. The middle one would be a solid. And the last one would be a gas. And the reason, the evidence that we have for this, the particles in the first one have a little bit of movement. They look like they have a little bit of space in between them, and they're really not organized. In the second one, there basically is no space in between them. They're very organized, and particular shape. And then the last one, they're not organized at all, and there's a bunch of shape in there. In our reasoning, what we would say is that a liquid, they're able to move. In a solid, they barely move at all. In a gas, they move a lot. And so that would be our answer. Moving on to our next one. It says entropy is the measure of disorder in a system. Which phase of matter has the lowest amount of entropy? So the disorder in a system. So we can go back and even look at our last example. Which one is going to be the most disorder and least disorder? Well, the disorder in the system, we want the lowest amount of entropy, so the lowest disorder. So which one of these is the most organized? Well, obviously a solid. Look at it, it's very straight, very in particular rows. So what we would say here is that when we're looking at the states of matter, solid would have the lowest amount of entropy. Last question. It says kinetic energy is the energy of movement. Which molecules will be moving faster? Dichloromethyl molecule at 100 degrees or dichloromethyl molecule at 200 degrees. Well, remember, the higher the temperature, the faster that they move. So the higher temperature is the 200 degree Kelvin molecule, and that would be moving the fastest.